Question number 2. Identify the system of inequalities whose solution set is represented graphically. I'm going to start with this line. My b value is 14. I just have to get the slope moving over 1 and then down 3. My delta x is 1. My delta y is -3. So that's -3 over 1, which is -3. My slope is -3. We end up with y. If this was just a line, it would be y is equal to -3x plus 14. But because it is a half plane, I'm looking at shading above and it's solid. It's y is greater than or equal to -3x plus 14. This is our next one. Our b is 10. Our slope is, we're moving over 1 and down 1. Over 1, the delta x is 1. The delta y is -1. We have delta y over delta x, -1 over 1, which is -1. If this was just a line, it would be y is equal to -1x or -x plus 10. Because it is a half plane solid line, so it's going to be, and we're shading below it, so it's going to be y is less than or equal to -x plus 10. Here is our b value is 5. Our slope, we're moving over 2, down 1. Our delta y is -1, our delta x is 2. -1 over 2, -1/2. Because it is dotted, it's going to be either less than or greater than, and we're shading above, so it's going to be greater than. Y is greater than -1 over 2. See, our delta y was down 1, our delta x is over 2, and then down 1, right? So delta x is 2, our delta y is -1, and there it is. Y is greater than -1 over 2x plus our b value is 5. Those are the 3 lines that we have. 1, 2, 3, that's all of them. Identify 2 ordered pair solutions for the system of inequality. Anywhere inside here, right? We could pick this point right here because it's on the lines, but they're both solid. This point, 2, 8, is a point. We can pick any point inside here, or that point, or that point, that point. That one's good, that one's good. This one's no good because it's going through the dotted line as well. This point's good. There's all kinds of them. I'm going to pick this point, 5, 4. There's 2 order pairs. Many other order pairs are available. C, calculate the coordinates of point P. So point P here. It's on the line y is equal to -3/4 x plus 14, and it's also on the line y is equal to -1/2 x plus 5. I'm going to equate those. I'm going to use the comparison method. I'm going to write my -0.5 as a decimal, my -1/2 as a decimal, which is -0.5 x plus 5 is equal to -3x plus 14. Which one's bigger, -0.5 or -3? Well, -0.5 is actually bigger. It's closer to 0. So I always want to go to where I have more x's, which means I really want to get rid of this -3x. So I'm going to add 3x to the right-hand side. And if I add 3x to the right-hand side, I have to add 3x to the left-hand side. 3 added to -0.5 is 2.5. We get 2.5x on this side. I want to get rid of this 5. I'm going to subtract 5 from the left-hand side, but if I subtract 5 from the left-hand side, I also have to subtract 5 from the right-hand side, giving me 9. We have 2.5x is equal to 9. The 2.5 is multiplying the x. I'm going to do the opposite. I'm going to divide both sides by 2.5. 9 divided by 2.5 is 3.6. Then I'm going to feed it back into one of my equations, either y is equal to -3x plus 14 or y is equal to -0.5x plus 5. I'm going to use the -3x plus 14. So y is going to be equal to -3 times the 3.6 plus the 14. Run that through the calculator. That gives us 3.2. So this point is 3.6, 3.2. Now let's see if that makes sense. So the x value here is 3, and they're saying this is a little bit more than 3.5, 3.6. That does make sense. Then this is the 3 going up, like we're going up 1, 2, 3, and a little bit, 3.2. Hey, that does make sense. So that's our point. We have calculated the coordinates of point P. And that's it for question number 2. Have a good day.